In this lecture, Integral Calculus, Lecture 2, we shall be considering how to integrate a function x raised to the power of n. In the last lecture, we established the need for arbitrary constant of integration, and we said for every indefinite integral, there must always be a constant of integration. So in this lecture, we shall be advancing to look at how we can integrate integrals with x raised to the power of n. Now, let's get into the lecture. Okay, recall that in differentiation, if y is equals to x raised to the power of n, then dy over dx is equals to n x raised to the power of n minus 1. That is from differentiation. Now, since we know that y is equals to x raised to the power of n, then it means that dy over dx, which is the same thing as d of x raised to the power of n. Remember, dy, y is x raised to the power of n. So dy means d of x raised to the power of n all over dx. And from the definition of differentiation, this gave us this, right? So that means dx raised to the power of n over dx is equals to n x raised to the power of n minus 1. I want to derive the formula for the integration of x raised to the power of n. So please follow me. Now, if we say replacing n by n plus 1, I want to check something similarly. So since I have that d of x raised to the power of n over dx is equals to nx n minus 1. So if I replace this n by n plus 1, I'm going to have, so we're going to be having something like this. D of x, no, this n is replaced with n plus 1. So d of x n plus 1 over dx. And now the answer here will give me n plus 1 x raised to the power of n minus 1. Okay, so now what this simply means is that d of x n plus 1 all over dx is equal to n plus 1 x. Remember, this was n here, so this would have been n plus 1 minus 1. Please take note of that. Remember, when I put n to be n plus 1, so this n here becomes n plus 1, this n here becomes n plus 1 minus 1. So 1 minus 1 goes. So I'm left with n plus 1 x raised to the power of what? N. Now, cross multiplying both sides, if I cross multiply, we are going to be having that d of x n plus 1 is equal to n plus 1 x raised to the power of n dx. So if I divide both sides by n plus 1, now I will have something like this. D of x n plus 1 over n plus 1 equals to n plus 1 x n dx over n plus 1. Of course, this and this will go. Now, when this and this goes, what I'll be left with is d of x n plus 1 over n plus 1 is equal to x n dx. Now, since the integral is the reverse of differential, so to remove the integral sign, what I will simply do is this. Since the integral is the reverse of differentiation, so if I want to remove this differential sign, so I will say integrate both sides. So integrating both sides, we have, remember, what am I integrating? I'm integrating both sides of this function. So what I will have is integral of d into xn plus 1 over n plus 1 equals to integral x raised to the power of n dx. Remember, I told you that integration is the reverse of differential. So if this and this cancels out, what I will be left with is what? Xn plus 1 all over n plus 1, which is equal to integral of xn dx. Now remember, whenever we solve an integration, we said always put an arbitrary constant c. So hence, what we have been able to derive is that the integral of x raised to the power of n dx is equal to x raised to the power of n plus 1 over n plus 1 plus c. This is the general formula for integration. Provided, the condition is that provided n is not equal to minus 1. Because if n is equal to minus 1, here will become minus 1 plus 1, which is 0. So our solution will be undefined. All that I have been trying to do from the beginning here is just to derive the general formula for the integral of x raised to the power of n. So even if you find it difficult to understand how I managed to come about with this formula, I want you to at least learn the formula, because what you need is this formula, that the integral of x raised to the power of n dx is equals to x raised to the power of n plus 1 over n plus 1 plus c, where c is what? A constant. Do you remember? C is a constant. I hope you understand what we have just explained. Okay, I want you to note, we gave a condition that this formula is used provided n is not equals to minus 1. But if n is actually minus 1, see what we're going to have. We will have integral of x raised to the power of minus 1 dx, and that will give us x, remember n is minus 1, minus 1 plus 1 over minus 1 plus 1 plus c. Of course, according to indices, x raised to the power of minus 1 is what? 1 over x dx equals to x raised to the power of 0, minus 1 plus 1 is 0, all over what? 0 plus c. And this gives us what? Undefined. So it is not defined. That's why we say that the integral of x raised to the power of n dx is equal to xn plus 1 over n plus 1 plus c, provided n is not equal to minus 1. Please, I want you to take note of this formula. This is the formula for the integral of x raised to the power of n, provided n is not equals to minus 1. Okay, how do we now find the case when n is equals to minus 1? How do we solve such integral? So please pay attention. To find the integral of x raised to the power of n dx when x equals to minus 1, Now, considering integral x raised to the power of n dx, this is when n equals to minus 1, please. When n equals to minus 1, we are going to have integral x raised to the power of minus 1 dx, and this will give us what? X raised to the power of minus 1 in indices is what? 1 over x dx. Now, recall that from differentiation, if y is equals to ln x, of course, you know that ln x is the same thing as what? Log to base e of x, right? Now, if y is equals to ln x from differentiation, and you are asked to differentiate this function, we say that dy over dx is equals to what? 1 over x. So, since integration is the reverse of what? Of differentiation. Since integration is the reverse of differentiation, so it therefore means that, remember, from differentiation, y equals to ln x, dy over dx equals to what? 1 over x. So it means that integral of 1 over x from differentiation will give us what? Ln x. So it therefore means that integral of 1 over x dx will give us ln x plus c. Or, remember I told you that ln means natural logarithms. So it simply means log to base e of x plus c. So please, I want you to note, whenever you are solving an integral of the form x raised to the power of n, where n is equals to minus 1, the solution is simply ln x plus c. Very important concept to note. Okay, let's look at some basic rules for differentiation. For integration. Some basic rules for integration. Now, there are numbers of rules that we need to take note of that will help us whenever we are solving integral problems. Basic rules for integration. The first rule I want you to note is the one we first derived, and it states that integral of x raised to the power of n dx is equals to x raised to the power of n plus 1 over n plus 1 plus c, provided n is equals to minus 1. This is what I tell my students. I tell them, just look at it this way. X raised to the power of n times x. Look at it. X raised to the power of n times x raised to the power of 1. Indices says this is what? Since the base are the same, so this is x n plus 1. Then this d simply means drop down the power. So that's just a simple trick, a simple concept I use in explaining this thing to my students. That x raised to the power of n dx is equals to x raised to the power of n plus 1 over n plus 1 plus c, provided n is not equals to minus 1. The second rule is the one we also explained, that integral of 1 over x dx is equals to what? Ln x plus c. And remember that ln x means what? Log to base e of x. Now, let's look at rule 3. Rule 3 states that if f of x and g of x are two functions, then the integral of f of x plus g of x dx is equals to, now you integrate them term by term. First, you take the first one, integral f of x dx plus integral g of x dx. Remember I told you that this is like the opening of a bracket and this is like the closure of a bracket. So whenever you put an integral sign, there must be a dx to close it. So we take them term by term. Integral of f of x plus g of x dx is equals to integral f of x dx plus integral g of x dx. Similarly, for subtraction, the same thing holds. Integral of f of x minus g of x dx is equal to integral f of x dx minus integral of g of x dx. I hope you understand the rules we've just established. That's rule 1 and then rule 2. Rule 1, rule 2, and rule 3. Now, I want you to note that this rule 3 can be extended. Look at it. This rule 3 can be extended to any finite number of functions. Any finite numbers of functions, this rule can also be extended. For instance, if you are asked to find the integral of f1x plus f2x plus dot dot dot, that is and so on till fn x dx. So this is simply equal to, take the first one, f1x dx plus f2x dx plus and so on plus f of n x dx. So for any numbers of function, you can always separate them and integrate each term. Rule 4, a very important rule too. It said that if p is any real number and f of x is a function, then the integral of p f of x dx is equal to, remember this is a real number, so it's a constant. You can always bring it out of the integral sign and then integrate the function. So that means this is equals to p integral f of x dx. So it means if I have, for instance, integral of 2x squared dx, I can always bring the real number outside. So to have 2 integral x squared dx. If I have 10x4 dx integral, I can always bring out the 10 to have 10 integral x4 dx and then integrate this. So what the rule 4 is saying is that for any real number multiplied with a function, we can always bring out the real number and then integrate the function. Okay, I hope you understand what I've been explaining so far. Let's advance. Now, rule 5. If p is any real number, then the integral of p dx is equals to px plus c. Please take note of this concept very well. You know, I started by, I think I made a statement earlier that if I have integral xn dx, what I simply do here is multiply x of n times x, so that is x of n times x to the power 1, and that will give me xn plus 1. Then this d is like dropping down the power. So the same thing is applicable here. P times x, that gives me px, right? Remember this plus c. Px raised to the power of 1 over 1 plus c. Of course, if you remember this is actually true. So for any real number p, the integral of that number with respect to dx is equal to px plus c. Now, I just want to prove this concept mathematically so you can see it. Now, check it out. Integral p dx is the same thing as, of course, you know that there is 1, or from what we just did from the rule 4, we just established that whenever we have a constant here, we can always bring it out of the integral sign, right? So let me just use the rule here in proving this rule 5. So if I bring this p out, I'm going to have p integral dx. Remember, there is a 1 here. So if there is a 1 here, you know that we know that, note, x raised to the power of 0 equals to 1, right? Good. Since we are working with dx, so this can be the same thing as p integral x raised to the power of 0 dx. And from our definition of integral, that integral of x raised to the power of n dx is equals to xn plus 1 over n plus 1 plus c, right? We established this earlier. So now, that means this will give me p into this x raised to the power of 0 become x raised to the power of 0 plus 1 over 0 plus 1 plus c. So this will become p x raised to the power of 0 plus 1 is x raised to the power of 1. So x raised to the power of 1 is what? X. So this is x over 0 plus 1 is 1 plus c. So this will now give me, if you this x to the power x over 1 is actually x. So p times s gives me what? Px plus c. Now some of you may be asking, why didn't I expand it this times this to get this, then this times this to get pc? Now I want you to just note that any number you multiply with a constant is still a constant. Any number you multiply with a constant is still what? A constant. Or if I am getting you confused, I could just solve it from here. Call this x raised to the power of 0 plus 1 over 0 plus 1 plus c. Maybe keep the c outside, maybe so that you will not get confused till we get to that point where I'm going to tell you that any number multiplied by a constant is actually a constant. So this is actually the proof of this particular concept. So please take note. Integral of a number, let's say 2 dx, is equals to what? 2x plus c. Integral of 7 dx is equals to what? 7x plus c. Integral of 12 dx is equals to what? 12x plus c, and so on. I hope you understand what we just explained, because we are going to be applying these rules now to solve some problems. Okay, let's look at the application of these rules in solving some classical examples. The question I have here is, determine the following integrals. Number 1, x raised to the power of 8 dx. Number 2, x to the power of 11 dx. 3, 5x raised to the power of 7 dx. 4, 8 dx. 5, integral of square root of x dx. And then 6, integral of cube root of x squared dx. Now, I want you to remember that our general formula, that if integral of x raised to the power of n dx is equals to what? X raised to the power of n plus 1 over n plus 1 plus c. So if I apply it here, I'll have this to be equal to what? This is actually, x raised to the power of 8 plus 1 over 8 plus 1 plus c. So this will give me x raised to the power of 9 over 9 plus c. That's the answer. As simple as that. Now for this, I'll be having this to be from the rule here. So this will give me x raised to the power of 11 plus 1 over 11 plus 1 plus c. On simplifying that, this will give me x raised to the power of 12 over 12 plus c. I guess this is very simple. Okay, let's look at the next one. Number 3, integral of 5x raised to the power of 7 dx. Of course, this is equal to 5, if I bring the 5 out, so I can have 5 integral x raised to the power of 7 dx from the rule we just established. Remember this rule, that whenever you have integral of p f of x dx, you can always factorize, bring out the p out, and then work with the function. So this is what I'm going to have. So this is now equal to 5. Now I integrate this. So this will give me what? This will give me x raised to the power of 7 plus 1 over 7 plus 1, then plus c. So this will now give me 5x raised to the power of 8 over 8 plus c. It's as simple as that. Or I can actually take it straightforward. Let me show you another alternative. I can also solve this thing this way. Alternatively, I can say integral 5x raised to the power of 7 dx equals to the same thing, 5x raised to the power of 7 plus 1 over 7 plus 1. Remember, we're working with the variable because we are integrating it with respect to x, plus c. So this will give me 5x raised to the power of 8 over 8 plus c. Same thing. I hope you understand what we have been doing so far, because I have some problems for you to solve at the end of this lecture. Okay, let's look at this one. Integral of 8 dx. This is very simple. When we applying the rule that states that integral of p dx equals to px plus c, provided p is a real number. So if I apply this rule, I'll be having that this means that integral of 8 dx is equals to what? 8x plus c. It's as simple as that. Very simple. Okay, now let's look at number 5. Number 5, integral of square root of x dx. Now remember, according to law of indices, square root of x is the same thing as what? X raised to the power of half. So this will give me integral of x raised to the power of half dx. When I apply my rule that integral of x raised to the power of n dx equals to xn plus 1 over n plus 1 plus c. So this will actually be equal to x raised to the power of half plus 1 over half plus 1. So plus c. When you solve this out, this will give me x half plus 1. If you do this fraction, this will give us 3 over 2. All over half plus 1 is what? 3 over 2 plus c. Now, this will be equals to x raised to the power of 3 over 2 divided by 3 over 2. Please, I want you to note this is what this means. This means x raised to the power of 3 over 2 divided by 3 over 2 plus c. When you simplify this, it will give me x 3 over 2. You change your division to multiplication and invert this, 2 over 3 plus c, which are now going to have 2x 3 over 2 all over 3 plus c. And that's just the answer. But if you want to still apply laws of indices to simplify this further, remember, in laws of indices, I want you to remember your laws of indices. Laws of indices. When you have, let's say, a raised to the power of 3 over 2, this is equals to, the 2 here represents the roots. The numerator here represents the power. So this is actually square root of a raised to the power of 3. I hope you remember that. So if I apply it here, I'm going to be having 2 square root of x all raised to the power of 3 over 3 plus c. So it means the integral of square root of x dx is equals to this. I hope you understand that. Okay, let's take number 6 question. I think that's the last question that we're going to do for this night, and then we'll look at some work to play with. Now, the last one here says find the integral of cube root of x raised to the power of 2. Remember, according to law of indices, cube root of x raised to the power of 2 is the same thing as x raised to the power of 2 over 3. I believe you remember that. So on solving this will be given as integral x raised to the power of 2 over 3 dx. Now, on simplifying this, so when we integrate this, remember our rule of integral, x raised to the power of n dx is equals to xn plus 1 over n plus 1 plus c. Now, on solving this, I will have x 2 over 3 plus 1 over 2 over 3 plus 1, then plus the constant of integral. Now, this is equals to 2 over 3 plus 1. Of course, when you do the fraction, I'm not actually here to teach you fractions. So 2 over 3 plus 1, this will give me x raised to the power of 5 over 3. all over, of course, 2 over 3 plus 1 is what? 5 over 3 plus c. Now, what this simply means is this. This means x raised to power 5 over 3 divided by 5 over 3, then plus c. Of course, this is x 5 over 3. You change the division to multiplication and invert this, so have 3 over 5 plus c. This will now give me 3x 5 over 3 over 5 plus c. And that's the answer. But if you want to still break it further, remember, according to the law of indices, if you have a raised to power of 5 over 3, the 3, which is the denominator, represents the roots, and 5 here represents the power. That's law of indices. Please go back to your indices if you have any challenge here. So when I apply these indices here, I'm going to have that the integral of cube root of x squared dx is equal to 3, then cube root of x raised to power 5 all over 5 plus c. I hope you understand what we have been doing so far. Okay, let me give you something to play with. Look at this. It's a leisure work. The first question here says, find the integral of x raised to the power of 100 dx. The second one, find the integral of 100 x raised to the power of 99 dx. The third one says, find the integral of 2 dx. The fourth one says, find the integral of cube root of x dx. The fifth question is, find the integral of x raised to the power of half dx. Please try your best to do this leisure work on your own before looking at the answers. So these are your answers. Okay, we have come to the end of this particular lecture. In our next lecture, we shall be looking at further examples on integrals. See you in our next class. Thank you for your attention.